So here is our first episode of Chemical Engineering Philippines interview questions. So ang pag-uusapan natin ngayon, what is the difference between thermodynamics and heat transfer? Nakita namin na isa to sa mga common questions na tinatanong sa mga chemical engineers during interview, lalo na when they are applying abroad. Maraming nako-confuse dito dahil it seems mayroong pagkakapareho yung thermodynamics at heat transfer. In fact, the word thermodynamics comes from a Greek word therme meaning heat and dynamis meaning strength particularly applied to motion. So it literally means strength of heat. And of course, heat transfer means the transfer of heat. So it seems meron siyang pagkakapareho. So pag-usapan natin yung pinagkaiba nila. Please like, share, and follow our pages in Facebook, Chemical Engineering Philippines and Nerds Philippines. Paki-subscribe na rin sa aming YouTube channel, Nerds Philippines, and hit the bell button para lagi kayong notified sa mga updates. Thermodynamics deals with equilibrium states and changes from one equilibrium state to another. So let's say meron tayong graph and meron tayong equilibrium state 1 at nag-change siya to equilibrium state 2. So itong state 1 natin nasa equilibrium state at ito namang state 2 is nasa equilibrium state din. So from this case, magagawa nating ma-determine yung amount of work and heat transferred from equilibrium state 1 to equilibrium state 2 through thermodynamics na may unit na joule. Pero hindi pinag-uusapan sa thermodynamics kung gaano katagal nangyari yung process na yun. So hindi concern ang thermodynamics how long the process will take. While in heat transfer, we are discussing about the heat transfer rate, which is in joules per second. Also, thermodynamics is not worry how the system has changed from equilibrium state 1 to equilibrium state 2. So hindi natin pinag-uusapan sa thermodynamics yung mode ng transfer ng heat. Paano nangyari yon? Samantalang sa heat transfer, pinag-uusapan natin yung modes of heat transfer such as conduction, convection, and radiation. So magbigay tayo ng analogy para madali natin siya maintindihan. Suppose you are traveling from Manila to Tacloban. So yung distance na tinravel mo, distance S, is analogous to the amount of heat or work in joule. Dahil mami-measure mo yung distance na na-travel mo from Manila to Tacloban, the same way naman sa heat. From equilibrium state 1, dito ang equilibrium state 1 natin is Manila, at ang equilibrium state 2 naman natin is yung Tacloban. So, nami-measure natin yung distance na tinravel, and of course, mami-measure din natin yung amount of heat. How about yung speed, distance over time? Analogous naman siya sa rate of heat transfer. So, kung gaano mo kabilis narating yung Tacloban from Manila, sa rate of heat transfer naman, makikita natin kung gaano kabilis narating natin from equilibrium state 1 to equilibrium state 2. Ngayon naman, paano ka nakarating sa Tacloban? Naglakad ka ba? Nag-land travel? Nag-aeroplano? Or nagbarko? Yan naman yung may kukumpara natin sa modes of heat transfer. Why there is a need to undertake a detailed study on heat transfer? Knowing the fact na makukuha naman natin yung amount of heat using thermodynamics alone, bakit kailangan pa natin pag-aralan yung heat transfer? Well, in practice, we are more concerned about the rate of heat transfer, the heat transfer per unit time, than we are with the amount of heat. For example, itong hot coffee na nasa loob ng thermos bottle. Alam natin na eventually lalamig yung hot coffee na nasa loob. Let's say, nag-drop yung temperature from 90 degrees Celsius to 80 degrees Celsius. So, using thermodynamics alone, makukuha natin yung amount of heat transferred. Pero, for the typical user ng thermos bottle or sa designer ng thermos bottle, we are concerned how long does it take for the temperature to drop. Dahil kung tayo magde-design, ang gusto natin na yung hot coffee na nasa loob ng thermos bottle ay matagal na lumamig. Determining the rates of heat transfer to or from a system and thus the times of cooling or heating as well as the variation of the temperature is the subject of heat transfer. Take note din natin, ang thermodynamics is an equilibrium phenomenon. It deals with equilibrium states and changes from one equilibrium state to another, while yung heat transfer naman deals with a system that lack thermal equilibrium. So it is a non-equilibrium phenomenon. Therefore, the study of heat transfer cannot be based on the principles of thermodynamics alone. However, the laws of thermodynamics lay the framework for the science of heat transfer. The basic requirement of heat transfer is the presence of a temperature difference. The temperature difference is the driving force of the heat transfer. So we hope naging helpful sa inyo ito, and we encourage our fellow chemical engineers to comment for additional information. We are also inviting you to join the Chindicato Facebook group.